Good morning Year 5, it is Wednesday's maths lesson already. So we are going to be looking at dividing a 3-digit by a 1-digit number today. We're going to be looking at applying it to our different chilies that we would like to have a go at. And again, I would love to see your work sent in to the Year 5 email address. So let's see what our lesson entails today.
Before we get started, I wanted to give a shout out to children that have sent their work in from Miss Taylorson's lesson. Now, as I'm recording my video slightly ahead of time, I'm sure there'll be lots more children that I can announce and give shout outs to for division. But this work belongs to Ollie G in 5W, and I was really impressed with how he has laid out his multiplication. It's easy to see and also shows me that he is understanding the concept of place value. Well done, Ollie. I'm awarding you 1 dojo point for aspiration. Keep up the good work. This fantastic piece of work belongs to Esther in 5E. Well done, Esther. Not only have you laid out your numbers correctly, I can see that you have worked really hard in working out your multiplication facts. I'm also going to award you a dodo point for aspiration. Now, it's really important, although we're looking at division for the next 2 weeks, that we remind ourselves of the 4 operations. So one of your starter tasks for today is to use column addition to solve the answers to these 3 questions. So pause the video now and have a go, and then we will share the answers together. How did you get on? Please don't worry if you've got a question wrong. Sometimes it just takes us to go back to our calculation and identify perhaps where we have not added correctly or maybe carried correctly. So don't panic, have a look back at your questions. If you've got all of those correct, well done, that's fantastic. Let's start now with our division lesson. Our learning objective for today is to divide 3 digits by 1-digit number. So if you have a look at our key vocabulary, you may notice that I have put the bus stop method in red. And I've put an arrow. This is what the bus stop method looks like for children who perhaps are not familiar with it. Now, I know at home that your parents, and myself included, would have been taught the bus stop method initially from the first thing that they would have learnt about division. Now, the reason we are looking at partitioning with place value counters and part whole models first is to build that basis for you to understand the bus stop method. It's all surrounding place value of each number. So I promise that the bus stop method is coming. It will be in tomorrow's lesson, but we're going to keep on with our part whole models so that the children understand place value. So let's start with our lesson today. Let's have a look at this question together. So we have 576 divided by 4. We are going to be looking at this with place value counters, but also alongside the partitioning method, part whole method. So let's have a go. So we have 5 hundreds, 7 tens, and 6 ones, and we are dividing that out into 4. So you can see 4 rows here. Let's start with this question. Okay, so we've managed to share out these 400s. Now look at this as a part whole model. We have the whole as 576, and so far we have been able to use the 400s. So we have partitioned the first part, the hundreds, into 400. However, we are not going to be able to share this 100 out 4 ways. So we're going to have to exchange that 100 for 10 tens. Okay, so you can see here that when we divide this by 4, we have 100, and we know that's right because in each row so far we have 100. So we're going to exchange this 100 for 10 tens, and here it is. Now we're going to share those tens out. Okay. Now you can see that we have partitioned 576 so far into 400 and 160. This is our tens. And we've divided that by 4 and it gave us the answer 40. Again, we know that's correct because when we did it with our place value counters, we have 40 in each row, 4 tens in each row. Now, we have had to exchange that 10 that we had because we couldn't share that 1 10 out into 10 ones. And now we're going to share our ones out. Perfect, it fits in exactly. So we partition that into 16 ones. Now we know that 16 divided by 4 gives you 4. Now what do we have to do to get the answer? Well done. We have to add these three numbers together. 100 plus 40 plus 4 gives you 144. Let's have a go at this one. 115 divided by 5. We have 100, 110, and 5 ones. Now, you can clearly see that we are not going to be able to share that 100 out over into 5. So what we're going to have to do is we have changed it to 10 tens, and now we're going to share the tens out. Okay. That 10 there, we had 1 left over. We have to exchange that 10 for 10 ones. And now we can share the ones out. If we look at this in a part-whole model, which is the focus for today, we are now properly moving into a part-whole model because we've looked at these place value counters in a lot of depth now. We can see that 115 can be partitioned into 100 and 15. And you know that because 100 plus 15 gives you the whole of 115. You know that both of these numbers divide by 5 because they end in either a 0 or a 5. So if we divide 100 by 5, it gives us the answer 20. And if we divide 15 by 5, it gives us the answer of 3. 20 plus 3 is 23. Well done. Now it's your turn. I would like you to have a go at these two questions. You've got 765 divided by 5, and then you have number 2, 201 divided by 3. Now, I would encourage you to use the part-whole model. If you think that you still need to use the place value counters method, then go for it. Pause the video now and have a go, and then you can unpause me and I will talk you through the answers. How did you get on? Let's have a look at the answers. 765 divided by 5. Okay, so here it is in a place value counters, place counters. So we're going to have a look at it in terms of the part-whole model. So focus on this section over here. So our whole was 765, and we could have partitioned that into 500, 250, and 15 because all of those numbers go into 5. They are divisible by 5. The answers at the bottom, 100, 50, and 3, you just have to add together to give you the answer to that question. So the answer to number 1 is 153. Let's have a go at number 2. Here again is the place value counters. Let's look at it as a part-whole model though. So the whole was 201 and we're dividing by 3. So you could have partitioned the whole into 180 and 21 because those numbers are divisible, they go into 3. So 180 divided by 3 was 60 and 21 divided by 3 was 7. When you add those two numbers together, it gives you 67. Well done. Now it's my turn. I'm going to have a go at this question. 776 divided by 4. I'm going to use a part-whole model. So I have to think to myself, how can I partition this number so that each of these numbers here are divisible by 4? Now I know that 400 goes into 4, can be divided by 4. So 4 goes into 400, doesn't it? But how many times? 100 times, because 100 times 4 is 400. So let me think. If I've partitioned 400, what's left? Well, so far I've got 376 left. So I could partition this number into 360. And I know this because 36 is divisible by 4. And this is just 360. It's just 10 times bigger. So 360 divided by 4 gives me the answer of 90. And I'm sure you all know this at home. 16 divided by 4 is 4. All we have to do is add these answers up. So 100 plus 90 plus 4 gives me 194. Chili 1, here is your first question. Eva is working out 844 divided by 4 using a part-whole model. Complete Eva's method. So pause the video now and have a go at question number 1, and then you can unpause it and I will show you question number 2. Here is question number 2. Again, a part-whole model. It says complete the part-whole models, and at the bottom it says what is the same and what is different about these calculations. Pause the video now, Chili 1, because those are your 2 questions. If you are Chili 2 today and you've decided that you're feeling quite confident, this is your first question. Whitney is using flexible partitioning, which means that she can partition it, or she thinks she can partition it in more than just one way. So she's done this so far, and each way she's partitioned it has been divisible by 4. Each number has gone into 4. Could she have partitioned her number another way? Pause the video now. It might take a bit of trial and error, this question. See if you think she could have, she might not have been able to partition her number another way. And then unpause the video and we'll look at your next question. Okay, question number 2 and 3 for Chili 2. It says use Whitney's method, so she used a part-whole model to work out these divisions. Once you've done that, look at the true or false question. To divide 639 by 3, you need to use the short division method. Is there any other way you could work out this question quicker and more easily? Pause the video now and have a go. Chili 3, here is your question. Dexter is calculating 208 divided by 8 using part-whole models. Can you complete each model? So you're basically filling out the answers here to each of the part-whole models. And then after that, how many part-whole models can you make, just like Dexter has, to calculate 132 divided by 4? Pause the video now and have a go at question number 1. And then unpause it, and I'm going to show you question number 2 for Chili 3. Okay, Chili 3, here is your final question. It says you have 12 counters and this place value grid. So here are your 12 counters and here is your place value grid. You must use all 12 counters to complete the following. So you've got one here, create a 3-digit number divisible by 2, and then try and create a 3-digit number divisible by 3, and then try and create a 3-digit number divisible by 4, and then a 3-digit number divisible by 5. And the final question is, can you divide a 3-digit number, or can you find, sorry, a 3-digit number that is divisible by either 6, 7, 8, or 9? So I want you to think about that. You have 3 different sections here because it's going to be a 3-digit number, so it's going to be hundreds, tens, and ones. Pause the video now. This might take you a little while, but it's just like we would at school, it's trial and error. So pause the video and just have a go at experimenting with these 12 counters. Okay, now is your warning that I'm about to read out the answers. So if you do not want me to read out the answers yet because you haven't finished, pause the video. If you are ready for the answers and you are ready to check through your work, you will need either a different colour pencil, crayon, or pen. So I'm going to give you a bit of time to go and get that, and we are going to have a look at the answers. First of all, Chili 1. Chili 1, here are the answers to question number 1. Pause the video and mark your answers against the answers on the board. Chili 1, these are the answers to question number 2. Again, pause the video and mark it against your work. Now we're moving on to Chili 2 answers. Now, Chili 2, it starts at question 2 because I want you to email in your answers to number 1 for Chili 2. So, could Whitney have partitioned her method in any other way? The answers for number 2 on Chili 2 are here. And the answer for number 3 was false, because actually 639 is easier to do in your head, isn't it? Because you can divide 6 divided by 3, 3 divided by 3, 9 divided by 3. These methods that I'm teaching you this week, you can do it in your head easily, then go for that, because it's about time, isn't it? So you know that that number there is very easily divided by 3 in your head. Pause the video and mark your answers against these ones. Chili 3, here are your answers. So I've put the question here, but your answers are down the side. So if you can just have a look at those answers. So pause the video and go through each of your part whole models to mark your answers. Here, this one, where the bottom question said, how many part whole models can you make to calculate 132 divided by 4? It says, children can make a range of part whole models, which means more than one. For example, 100 divided by 4 and 32 divided by 4. So you could have partitioned it into 132. So pause the video so you've got time to mark those answers, and we'll move on to question number 2 in a moment. Chili 3, here are your answers for the final question on your chili. So if you work down the answers from here, they are in red. Now at the bottom, where it says possible answers, it's talking about the final question, where it said, can you find a 3-digit number divisible by 6, 7, 8 or 9? So if you were looking for the ones that were divisible by 6, it would be any even number. If you were looking for 7, you would be looking for the number 714. If you were looking for divisible by 8, you would have been looking for the 3-digit number of 840. And 9, it is impossible. Pause the video now and mark your answers against the answers on the board. And finally, so your Timetable Rockstar session ended today, but I have started another one, a slightly different one. I've done a sound check session. So the reason there's got 4 here is because you need to play 4 of those games, and it starts from Wednesday the 27th, so today at 3 p.m, and it ends on Friday at 3 p.m. I will be looking for any children that are really standing out on the leaderboards to award dojo points to.
Wednesday's lesson is complete. Well done. I will see you here again tomorrow for our Thursday's lesson, again on division, but looking at slightly bigger numbers this time. See you tomorrow.